Hey guys, so today we're going to talk about the 7 mistakes every CNC beginner makes when they're first starting out. Let's get right into it. Mistake number 7, not knowing how to charge for whatever product you're making. Notice I didn't say not knowing what to charge. What to charge and how to charge are 2 totally different things. As a beginner, I think it's more important to understand how to charge than to know exactly what to charge, because you're learning. So, how to charge comes down to 3 different categories. You have your material cost, you have your machine time, and you have your personal labor time. Material cost, to me personally, I take material cost and mark it up 30%. So if something costs me $10, I'll mark it up 30% and sell it to the customer for $13 in material cost. Next is machine time. That is going to vary greatly depending on what machine you have and how often you use it. So if you have a $5,000 machine, but you only use it 2 hours a year, well, your machine cost is going to be much higher than the person that has a $5,000 machine and using it 20 hours a week or 40 hours a week, right? So machine cost is also going to be varying dependent on what type of machine you have and how often you use it. The next one is personal labor. Personal labor is the most overlooked thing by beginners when they're first starting out. So when you're first starting out, you think, oh, my time doesn't matter much, I'm learning and this is the learning curve. Well, let me tell you, you will never stop learning on the CNC. So as soon as you get the very, very basics figured out, you can start charging for your time because you're always going to be learning. I've been doing this 6 years now, which is not a crazy length of time, but I'm still learning every single day. So make sure that you're charging for your time. Now, what the value of your time is, I can't help you with that. If you're retired, your value of your time is going to be totally different than if you're a single mother with 4 kids, right? So understand what you're worth and actually charge for that when you're doing a product, because that's very, very important when you're first starting out. So before I go on to the next mistake, just know that I'm giving a summary of what I think is important for beginners to know. If you would like a more in-depth version of whatever I talk about or other topics, please comment in the comment sections below, and I will gladly make a video more in depth of whatever topic you're wanting me to talk about. Thank you. Mistake number 6, not understanding your machine's capabilities. So whether you have a machine like this, a machine like this, a machine like this, a machine like this, you need to know whatever it's capable of. You need to know how fast you can run it, how slow you can run it, what horsepower you have. That's all going to determine what you can cut with it or what size bits you can use. So when I was first starting out, I always made the mistake of running my machine way under its full potential. And we'll later learn in these couple other mistakes how to actually maximize that potential and what mistake I always made. Now, with that being said, you have to understand what your machine is capable of. Most beginners, when they're first starting out, are not going to utilize their machine to its full capacity. And that's okay. You need to learn. You need to test it, right? But when I was first starting out, I was so scared to go ever above this 1/4 inch bit, right? And then I got kind of brave, and so I started using bits like this one that are made for the bigger models of CNC, right? So this is a 1/2 inch bit, 2.5 inches or 3 inches long, and this is a 1/4 inch bit. Huge difference in the size, huge difference in the capabilities of whatever machine you have to run, right? And so just know that a hobby machine like this will never be able to do what this bit needs to do, right? Maybe a bit like this is a lot more suitable for a machine like this, right? So as you're going through the machine and as you're learning, be sure you know that you cannot run this bit through this machine and expect it to do the same thing and provide the same power as a bigger machine would. But also know that maybe you're running this bit way too slow or way too fast, which we'll get in later, or you're overdoing it or underdoing it. I actually had, in my past, I ran this bit on this machine to try to cut out something that I definitely should not have been cutting out, and believe it or not, it actually started bending this right here. It started bending this giant metal plate, this bit right here, right? So that was far exceeding this machine's capabilities. But this bit right here will probably never hurt this machine unless you're just absolutely just going crazy fast with it, right? So understanding your machine's capabilities is very important, And be sure you're not babying it, and also be sure you're not doing what I did and trying to force it to be this giant Hulk machine when it's really just a hobbyist machine. Mistake number 5, proper maintenance to your machine. Now, your machine's expensive, most likely, so you need to give it the attention it deserves. Now, my machine has lasted me all 5 years. I've probably put over 5,000 hours on it. There's been weeks I've ran it 80 hours a week. There's been days I've ran it 24 hours a day, right? So making sure that my machine is correctly lubricated is very key to lasting cut quality and the longevity of your machine. Now, I'm going to show you the 3 things that I've used throughout the years to maintain my machine and keep it working properly. So any moving parts need to be oiled and greased some way, shape, or form. The most important things I typically grease or oil are anything that's really guiding the machine along, guiding the bearings along. So you have these rails, a ball screw, a rail and ball screw on the Z-axis, and then whatever is right here that moves the machine forward and backwards, right? So I typically use, I personally have always used this like a garage door lubricant, which is a silicone-based lubricant that, you know, it doesn't attract dust, right? So I don't like to use heavy grease or oil or anything like that because it attracts dust, which may cake up on your machine, which may over time build up, and it's not good, right? So I always just used a silicone-based lubricant that I've always just kind of just sprayed on my machine every once in a while, and then I just wipe it off. And that's it. Super simple, nothing to it. And I say every once in a while, I mean, you know, if I'm not going to use it for a long time, I'll spray it on there before I leave, and then when I come back, I'll spray it on there again. Or if I've been running it heavily all day, maybe I'll do it at the end of the day. Once again, it takes about 30 seconds, but it will pay for itself, I promise. And if you ever have any rust spots on your machine, maybe you let it sit and didn't lubricate it or anything like that, just a Scotch-Brite pad from your neighborhood Walmart. Just go to the kitchen section, pick up a little Scotch-Brite pad, buff off the rust. Do not use sandpaper. Sandpaper may scratch whatever moving part it is, and it'll distort your cut just a little bitty bit. So a Scotch-Brite pad work just great. So the 3 things that I've always used to maintain my machine were silicone-based lubricant, a rag, and a Scotch-Brite. Mistake number 4, not understanding there's a learning curve and thinking you're going to be an expert. All right, guys, so I've been doing this for 5 years now. I have 4 different CNCs, 2 different brands, and really 3 different sizes of CNCs. And I am still learning every single day. I know people that have been doing CNC machining for the last 20 years, and they still make mistakes. So as a beginner, as you're going through this process, as long as you understand that mistakes are going to happen, you'll be in a lot better shape. I remember the first thing I ran on it, it took me, I think, 6 or 7 different tries just to learn how to set an origin and how fast to run my bit. And so just know that you're going to break bits. You're going to dig a giant hole into a project. It's going to slip out sometimes. You're going to run over a hold down clamp and break your bit, and the clamp's going to bend, and your spindle may hit something. Just know that those things are going to happen, and they really don't stop. You're going to make these minute mistakes of maybe you don't set the correct thickness of your material, or you don't go in the right spot, all that stuff. Mistakes are going to happen. Just know right away that, you know, that is never going to stop. I'm sorry, it's not going to stop. So as you go along, just make sure you understand this concept, because this is a very complicated machine that's capable of a lot of stuff. And for you to expect to learn it very quickly is not going to happen. It's unrealistic. So take all your mistakes and try to learn from them, just like everything in life, and you'll get there. You'll get and you have a better grasp and understanding of what the machine's capable of and what you're capable of running with it. Mistake number 3, not using the correct material. So today I have with me 3 different pieces of wood, and all of them are wood, right? But all of them are going to mill totally differently, and they're going to be used for different applications. So I have a piece of plywood with me, just a piece of pine plywood. I have a piece of walnut, and I have a piece of just a 2x8 piece of pine, right? Each one of these are all wood. They're all from trees, but they're all going to mill totally differently. Now, if you're using plastics or acrylics or corian or something like that, they all have different densities. They're all going to mill a little bit differently. But those are they're a homogeneous product. So once you figure out how to do one sheet of acrylic, you'll kind of figure out how to mill all sheets of acrylic, right? But wood is particular in that, each different species of wood is going to mill differently and have different tendencies. And then you have plywood, and then you have MDF, which is micro density fiberboard, if I'm not mistaken, right? And so it's a whole bunch of tiny particles of wood all glued together, right? So now you're worried about cutting through tiny particles that are glued together. And this, you're worried cutting about, in this piece of plywood, you're worried about layers that are glued together that you're cutting through. In pine, it's a little bit softer wood. In walnut, it's a little bit denser wood, right? Or walnut or maple or oak or whatever dense wood you're working with, right? So let me give you an example. So if you want to do a 3D carving, you probably would not use plywood for a 3D carving because the layers would chip out. Likewise, you probably wouldn't want to use pine for a 3D carving because it's so soft that you're going to have it's maybe really fibrous, right? It may have a lot of fibers and the carving's not going to come out well. But if you're testing a carving, you may want to use pine. And pine may work for carvings, but for me, when I do 3D carvings, I like to use something denser like walnut or maple. Something that has a very tight grain, and it carves. And it carves very well and holds detail very well. But now, if I'm cutting out simple cutouts, walnut is very brittle and kind of hard on your bits. So it's going to cut, and you may have to cut a little bit slower and not cut as deep on a piece of walnut as you would with a piece of plywood or a piece of pine, right? If I was first starting out as a beginner, I would probably use pine as much as possible, because pine is very forgiving. Just buy a 1x4 at the store or a 1x6 or even this pine plywood, right? If you're learning how to do cuts, just cut out a piece of plywood or, just cut out of a board, right? Because it's very forgiving. It's a softer wood, so if you're too fast or you're too slow, it's not going to do any harm to your machine or your bit because it's just softer, right? Where walnut, you have to be more exact, or maple, or whatever hardwood you're doing, any kind of dense wood. You're going to have to be more exact and kind of know your feeds and speeds and know what kind of bit you're using a little bit more. So choosing the correct material for the job is something that you're going to learn over time, but it is a mistake that you're going to make in the beginning. Even when I do walnut and oak, even though they're both hardwoods, they're going to mill totally differently than you would ever think, right? So just know as you're going through this, you're gonna make mistakes and learn what material is the correct material to use. Mistake number 2, not using the correct bit for the job. So in the world of CNC, there's hundreds and hundreds and hundreds of types of bits, but really it narrows down to 4 categories. Category number 1 is your sign making bits. So that's your V bits. They typically come in a 90 degree, a 30 degree, and a 60 degree size. That's just a typical 3. They may come in more degrees, but your typical one is 30, 60, and 90 degrees. Then the second type of bit is your profile bit. Your profile bit puts that nice edge on whatever you're making. It puts a nice profile, right? And so a profile bit may also go on the inside of your material and make some kind of nice decorative design. Your other types of bits, you have your straight edge bits. Those are the bits you can buy from Home Depot that typically have 1 to 2 blades on each side. And those are just the ones you probably grew up with that your father or your mother used when they were working on stuff. And then you have your end mills. Those are the ones that have really cool spirals and they look really cool, and you really didn't probably see them until you got into CNC machining. Those are the most popular types of bits for CNCs. Out of the compression bits, you have, there's numerous types. There's all different shapes and sizes, all different possibilities, but just know compression end mill bits, so just know end mill bits are the really cool spiral ones, okay? Now, out of the end mills, for beginners, we're going to talk about the basic 3. You have upcut, downcut, and compression. So I have today with me Fred. He's the box that's going to demonstrate what an upcut does, what a downcut does, and what an end mill, and what a compression does. So, an upcut bit, how it works is that whenever it cuts on the side of your material, okay, the spirals are designed in a certain way, at a certain angle, at a certain degree, that they make your chips go up, or whatever material you're cutting, the particles, that makes them shoot up. So whenever the bit, my arm is the bit, whenever it's running across your material, it's going to want to send all these chips upwards. What happens when it's sending these chips upwards and ejecting them from your material, it leaves a little edge on it, okay? And so now, I'm your upcut bit, I'm cutting, and I'm cutting, and I'm cutting, and I'm cutting. Well, what it's going to do is leave a rough top side and a clean bottom side. So an upcut, once again, is known for leaving a rough upside and a clean bottom side. Once again, because the bit is cutting and pushing chips upward. And this is kind of fibrous on most wood, and so it's kind of going to leave like a fibrous edge, you'll notice, okay? A downcut is the exact opposite of that. So a downcut bit, now, Fred's not happy, okay? And so a downcut bit, what it does is it cuts, okay, and sends your chips downwards, and most likely a downcut bit, all the chips are going to stay in whatever path you're cutting, okay? So they won't get ejected upwards. Okay, so your bit's going to cut, sending all your chips downwards. It's going to leave a clean top side and a kind of like a loose bottom side. And a lot of times this will curl under or curl out, or it'll bend a little bit, and so you won't get a super clean cut on the bottom side. Okay, now let's get on to compression bit. So a compression bit is the best of both worlds. It has a upcut side on the very bottom part of it, and then a downcut, usually a 1/4 inch up on whatever bit you're using. So what it does whenever you're cutting out material, so let's say you're cutting out, I don't know, whatever material you're cutting out, it's going to leave it's going to go up on a certain part, and so it's going to leave the bottom edge clean, and then it's going to go down at a certain point, and it's going to leave your top edge clean. So just know a compression bit has an upcut on the bottom and a downcut at some point on the way up the bit. Personally, a smaller CNC like this is probably not going to use a compression bit greatly, because you usually have to take a 1/2 inch pass with a compression bit. Even the smallest compression bit, you have to take a 1/2 inch pass at a time. And sometimes, depending on what material you're using, this machine may not be capable. I personally don't use compression bits that often because it's just not what I need and not what I'm doing. But there is huge benefits in using a compression bit when you want a clean edge on both sides. So once again, an upcut bit is going to leave a bad bottom side, or a bad top side, a clean bottom. A downcut bit is going to leave a bad bottom and a clean top, and a compression bit is going to leave a clean edge on both sides. Now, the thing I would use an upcut bit for, let's say you're cutting out a piece and you need the edge, you're going to be able to router off, right? You're going to put a round over bit or something like that on it. So whenever you're cutting, it's going to cut your material out, and you're going to have these edge on all the sides. Well, now you can just sand it off, and then you have a nice clean edge, right? And a downcut bit, say you want this top side to be very clean, and the bottom side you don't really care about, that is when you'd use a downcut bit. And a downcut bit may leave some frizzies like this on the bottom side, but it's okay because it's not going to matter, or you can, once again, sand that off. Now, in an upcut bit, what it's going to tend to do also, it's going to tend to shoot, as it's shooting your chips upwards, it's going to want to pull your material up. So on an upcut bit, make sure that you have enough hold down clamps so your material that you're cutting doesn't bounce around and vibrate. And like a downcut bit, it's going to want to hold your material almost down to the table. So if you don't have sufficient clamping, I would go with a downcut bit, because it's going to want to tend to hold your material down to the table. So the moment we've all been waiting for. The #1 mistake CNC beginners make when they're first starting out is running a bit too slow. And I see this happen with every CNC beginner that I ever met, and it also happened with me. So I know this from personal experience. I'm talking from personal experience. Most of you, if not all of you, are probably running your bit too slow. What happens when you run your bit too slow is that you have burnt edges, bad cut quality, it's taking longer to do a project, so maybe now that project's more expensive. And last but not least, and the most expensive thing probably, is that you're burning up your bits, and they're either breaking or they're turning black. I'll show you a couple pictures of mine that happened. These are actually my bits that I've burnt up in the past. But you know, the overarching thing is always running your bit too slow. Logically, it makes sense to run it slow, right? Because you don't want to hurt the bit or break the bit, or you know, hurt the machine, and maybe, you know, you just want to baby the machine, right? Because it's very expensive. But that is the wrong way to think about it. And once again, understanding your machine's capabilities and what bits you use, all this kind of falls into play. But whenever you run your machine, whenever you run your bit too slow, why it gets warm is that it's starting to rub, okay? And whenever it rubs, if you think of, let's go with your hands, right? So whenever what a bit wants to do is cut, okay? So what a bit wants to do is cut wood fibers, kind of like this. It cuts, and it comes around and cuts again, comes around and cuts again, and cuts again, okay? But what happens when you run it too slow is that friction starts to build up, right? And it starts to build up, and immediately it starts to get hot, just like your hands would. And all of a sudden, it starts with this screaming noise like, and then, you know that your bit's running too fast. So if your bit is screaming like that goat, you're probably running it too slow. And what goes around the industry is that if it's screaming, it's probably screaming for more. So feed me. So 2 things you can do to stop that screaming, which probably means that the bit is heating up and it's becoming a dull bit, is you can either A, slow down your RPMs, or B, speed up your feed rate, depending on what your machine is capable of. Hey guys, thanks for watching. I really hope y'all learned a lot. Please let me know in the comments below any future videos you'd like me to do. Give me a like, and don't forget to subscribe.